Right, hello again. I will send a link to the chat. If you could please respond. There's only one question, and it is anonymous, but we do want to know a little bit more about you. So there's one question: which subjects you take for A levels? So if you could just click on the link and answer one single question and submit. Thank you. All right, excellent. Okay. So I see some of you don't take further maths. Okay. All right, 96. Excellent. Okay. Okay. So even though it is possible to take the course without taking further maths, I do have to say that even though the topics that will be covered in the course during the year, we don't take purely further math topics. Yes, we do some elements of further maths, but we do always explain how they work. But some of the problems require a level of thinking which is closer to further maths. So just a heads up on that. And we have let me introduce myself. My name is Vlad Chernov. I am I'm a teacher in the UK. So I've been a teacher for about 16 years. And originally I come from Russia, and from one of the top universities in Russia, if not the top. There's always a debate about that, which one of the two. And at my university, we had a very similar program where high school students received assignments from the university. They completed the assignment and sent the assignment back, which was marked at the university. And then through this process, they developed their problem-solving skills, which is a very important thing in the modern world. And so yes, I live in the UK, not far from Oxford, and I'd like to welcome all of you to the course. And I think so I am I'm the academic coordinator for COMPOS for the online school. I design all the assignments, and I will be guiding the tutors that will lead you through the process. So we won't normally have these kinds of webinars for 100 participants. Normally, this will be a tutor and six students. Okay, so you have the opportunity to ask all the questions that you can. And yes, and off to Alex. So.
Nice to meet you guys. Yes, I'm Alex Lvovsky. I'm a professor in the Department of Physics at Oxford. So welcome. I'm very happy you are joining us, and I hope that we'll have a very productive year together, if maybe a couple of years, hopefully. But here for now. Yes, I'll just say a few words, basically of organizational nature. First of all, you have to, something that I'm afraid I might not have emphasized enough on the webpage, you have to take both subjects, so you cannot choose math or physics. So we're basically the whole program is envisioned as an integral program that combines both subjects. So you should do homeworks on both. Now, there will be tutorials, there will be webinars, as Vlad has said. So we'll see how often we repeat those webinars. So for now, we plan 2 webinars. They might be regular, might not. We'll see. We'll also have to see, look at your response. If you feel that you need them, then we'll have more webinars. If not, then we just restrict ourselves with the tutorials. Tutorials are not, well, webinars are certainly not mandatory. They're just for you. So we'll be reviewing problems that might help you solve the homework. Tutorials are also not mandatory, although you should make your best effort to attend them, because that's where you get a chance to actually interact with the teacher, ask them questions and so on. That's really important. What is mandatory, what we really hope that you will do, is the homeworks. Right, so homeworks are difficult, as you have seen. In fact, the first homework is unusually difficult in the sense it's larger, right? Because you have more time to work on it. So it's somewhat larger than the usual homework. The usual homework will be given every 2 or 3 weeks, both in math and physics. Yeah, and so the scheme, if you've seen the introductory video and the description on the webpage, you've seen the scheme. You have to submit the homework by the deadline. There is an email address, compos.oxford@gmail.com, to which you send the homework. Then your tutor, so the first homework will be just, marked by tutors altogether, but then your tutor will mark your homework and send you their markings. And then in the tutorial, they'll review those problems with which their students had difficulties. Yeah, what else? For the tutorial, it's good to have something to write on for an online tutorial. If you have an iPad or a tablet computer, that's perfect. If not, you can also get a so-called stylus pad. So it's a device that looks like this. It's like an iPad, but doesn't have a screen. You connect it to the computer, to your computer via a USB cable, and then you write on it with a stylus, and whatever you write appears on the screen. With some practice, you can the quality of writing can be almost as good as with an iPad. And it's kind of good to have it, because then in the tutorial, the tutor will sometimes ask you to solve a problem, so you can solve a problem and show your solution to other members of the group and so on. It's a good thing to have. Not mandatory. You can, of course, if you cannot afford it, you can always just show your writing like this on the video, but that's not, that's difficult to see, so it's not the optimal way. How do I do the poll? There was a link that Vlad has sent higher on the chat. So please send your questions to the chat. I think since there's so many of you, it's difficult to respond to oral questions, but please send your questions to the chat, and Vlad will try to answer them. And also, we'll create some kind of forum for the communication of the entire group. Because we're doing it for the first time, we don't know what the best format for the forum is. It might be just as simple as a Telegram group, or it might be something more sophisticated, or it might even change in the process. Yeah, hopefully there will be so we will create a forum. Please don't write the direct answers to questions to the forum, but of course, you're welcome to communicate in that forum. You're welcome to communicate in hints. So, if somebody's having a difficulty, you're welcome to help, but the help must not constitute the solution or the answer to the problem. Just more like what to read or what to pay attention to. I don't think I have anything else to say. However, I'd like to give the podium to Sean Tidaldi, who is our safeguarding lead and who's responsible to the university's outreach work with children, and she'll say a few words to you as well.
Yes, very briefly, just to introduce myself. So Obviously, your safeguarding is a top priority and your welfare. So I'm the designated safeguard lead for the department. So it's my responsibility to keep you safe and well during events. So if you have any concerns at all for any reasons, such as you're feeling unhappy, unsafe, you have concerns about another student or adult helper, then please do get in touch. I will send you this information with my email address to make sure you've got access to it. But I will be popping into your tutorials, probably you'll get to see me as we go along. So don't worry about that. It's just me checking everything's going okay. And I will see you on and off over the entire course. And I wish you well, and I hope you have fun doing all the physics. And if, as I said, any concerns, just get in touch. Thank you.
Yeah, thank you. So thank you, Sean. There was a question I see, is the completing of the question on the problem sheet mandatory? The answer is try to do it, try to complete all of them. However, don't despair if you don't, right? So we do expect you to solve most of them, right? However, sometimes we will give you deliberately difficult questions, challenging questions to challenge you, to make you, make an effort. If you're unsuccessful, then we'll discuss it in the tutorial. So that's question number one. Another question.
I'd like to add to that. If you weren't successful, you should submit your unfinished solution anyways, because you might be able. We will see how what your thinking is and how you're progressing towards the problem. So even if you didn't arrive to an answer, please do submit. And I can answer one of the other questions. It is perfectly okay to attach it as a PDF file. So you can write it on paper and then submit it as a PDF scanned version or photographed version, but it has to be very easy to read.
Right. Yeah. Then who will our tutors be? Yeah, it's most of them are current Oxford students, graduate or undergraduate. There's I think 1 or 2 postdocs and 1 visitor. How strict is the acceptance into the course? Basically, if we see that you have made a serious effort with the homework, and serious effort, I think if you make a serious effort, you'll be able to solve most of it, then we'll accept you. And then you have to keep up, right? You have to continue. So continue preparing good homeworks, and then that means that you remain in good standing. Will we know if we have been accepted? When will we know if we have been accepted into the course? So the deadline is on the 15th. We hope within a week to mark everything, and then we'll mail you. When will we receive? Will we receive a recording of this and all webinars, tutorials? Yes, I think Vlad is recording everything, so he'll post it, I think, on his YouTube channel. All right. Yes, I'll stay here, but I will be quiet, and I'll let Vlad continue.
Yes, this webinar is being recorded, as is the next week's webinar. When you are working with tutors, this is up to the tutors. I will ask them to record. Yeah. So just a few things. Notepad for workings, yes, perfectly acceptable. Well, we know, so as Alex said, which will take us about a week to mark. So the week beginning 22nd of November, you should all know. Right. Okay. Yes, Oxford student. Know if we have been accepted into the course. Receive the homework. The homework has already been published. The first homework has already been published. It is on the website. I will send you a link just so that you have it. And so I believe that is the correct link. And just one more one more thing before we start. So this is why we're here for, what we're here for. So this webinar will last about an hour and a half, and I will be going through very similar problems to those in the first maths assignment. Okay, And before we start, I have a question about the assignment, how you found it. So I will send you another poll. This contains 4 multiple choice questions. I'm sure you can finish it in less than 30 seconds. So just a very quick feedback about the difficulty of the first assignment. This poll is anonymous, so please be brutally honest and please please respond. Okay. The questions are quite self-explanatory. So today we do maths, and next week we will do physics. So today we're doing quadratics, and on the 9th of November, in a very similar setting, we are going to do vectors. Send them to email. So you can scan them with your phone, make a PDF, and send it as a PDF. If you don't know how to do that, you can Google it, and there are very easy instructions how to do it. Questions. Which assignments are you referring to? I'm not sure I understand the question. Haven't done the assignments are due, both assignments, the physics 01 assignment and maths 01 assignment are due on the 15th of November. So you have 2 weeks, just under 2 weeks to finish them. I will be guiding you through this and in next week's webinar, and we might need an extra webinar. The recordings will be, the links to the recordings would be either sent to you by email or they will be published on the website. The tutorials, lots of questions. The tutorials will take place, so you will agree with your tutor which day is best for all of you, for all 7 of you. So there will be 7 students and 1 tutor. So you will agree on a certain time that we should meet every week, and if there are holidays, you can arrange around that, so you can shift the session to a week early, to make 2 sessions on a week. But this is all agreed with your tutor. How the course will last for 1 year, so all throughout year 12 until the end of the academic year. It is okay to be more confident in one subject than the other, but physics and math, they both support each other. So getting even more confidence in one of the subjects builds confidence in the other one as well. So that's what we're here for. We are here to build your confidence in both subjects, and you don't need to worry if you don't. If you don't see, as far as I can see, everybody's taking physics. Well, 98.3% of you are taking physics, and 98.3% of you are taking maths. So I don't see any issues here. Just a quick look on the difficulty of assignments. If you haven't responded about the difficulty of the assignments, can you please do that now? Probably don't. If you haven't seen the assignment, please don't respond. Yeah, that information wouldn't be very useful to me. Should have respond. You just click on the link. I'll send the link again. You just click on the link and choose the options and press submit. That's all you need to do. And okay. That's okay. Challenging. All right. Physics assignment. Challenging, very challenging. Okay, so I see that most of you found the physics assignment more difficult than the maths assignment. Okay, good. That's important information for me. Right. So without any further ado, I'd like to start our webinar. Do these sessions prepare you better for the entry exams? Yes, we don't specifically prepare you for Oxford exams, but we do include questions from the Oxford entry exams into, as you have probably seen. So hopefully you will be better prepared, even though our aim is to develop your problem-solving skills and rather than promise you acceptance to one university or the other. No, we prepare you for yes, so you become a better problem solver. Handwritten scanned assignments absolutely can be accepted, and I think that's the preferred way, because it's very difficult to type maths formulas. At least for an unprepared person, definitely handwritten and scanned is the best way to do it. They should be submitted by email. The email is given to you. The email I will just send. The first assignment. This is the email for the first assignment. Okay. gmail.com. Okay, excellent. Right, I'm going to share my screen, and okay, so welcome to COMPOS, and we are going to go through 8 problems today. And maybe if we have more time, we'll touch some physics problems. But today we're focusing on maths and on the quadratic functions. It's mostly going to be me talking. I will sometimes look at the chat. It's up to you. So all the materials that I'm going through here will be available to you. I will send you a link so you can look back to this whiteboard. This is a virtual whiteboard which you will all have access to. So don't worry if you miss some of the notes, they will all be here. So problem number 1, find the vertex of the parabola. Of course, here you can use the formula which is given in the assignment, but I'm going to do it a different way, because one of the questions was to prove the formula. And this is done by completing the square. So here I can take 3 out of the brackets, and I'm left with x squared minus x plus 4/3. I hope nobody has any problems with that. And I'm using square brackets because I'm going to use round brackets as well. So completing the square, using the formula to complete the square, gives you x minus a half squared and minus a quarter. Yes, so if you follow the formula for completing the square, it's minus a quarter, and plus 4/3, which we have left over. Okay, so combining that, we can see, so 3 square brackets, square brackets. So we have x minus a half squared, and this brings us to plus 13 over right. So just looking at my notes, 13. Just a second. Sorry, I've got an error in my notes. Apologies. 2/12. Okay, yes. 13/12. Okay. And of course, we get rid of the square brackets, so we get 3x minus a half squared plus 13 quarters, 13/4. In maths, we prefer to use top-heavy fractions. And now let's analyze what we have in front of us. In front of us, we have an expression which contains x minus a half squared. And we need to find the vertex. And if there's something we know about the vertex is the lowest point. So it's the minimum point. It's a point where y is a minimum. Therefore, if we look at this, we can see square. Something squared is always positive, or at least it's non-negative. So the lowest possible value for this part is 0. So this part is greater or equal to 0. And therefore, if we look back at this, we will see that this has to be greater or equal to 13/4. So we have achieved the y coordinate of the parabola, and now we need to find the x value, which is and this is achieved when this is 0, because the minimum value for this is 0. So x is going to be a half. So x is going to be a half. Right, so that is for the first question. You will have a similar question to that, which looks like this. Apologies if the mouse is clicking. So you need to prove this. So this is problem number 1. And if we go here, you need to prove that. So basically, you need to do the same thing that I've done, but with A, B, and C. And if you do it very accurately, you would be able to prove that. So I hope that makes sense. Okay. Now, one of the other questions was about symmetry. And this is quite an unusual question. I don't think you normally see it in your A-level books. But you need to prove that x equals 3 is the line of symmetry for the graph x squared minus 4x plus 7. And as a hint, I've put here that x equals a is the line of symmetry if this is true. Now, as a good exercise, I do advise you to try to understand why. So why this is true. So if this is a line of symmetry, and the graph is symmetrical relative to this line, so let's say the graph is, well, okay, I'll make it simple. So I'll just draw a parabola. So the graph is symmetrical about this point. So this point, so this is A. This is A minus x. And this is A plus x. And you can see that the y values are the same. But it's once you understand why this is so, the process is very straightforward. So basically what you need to say is that, well, f of x in this case is x squared minus 4x plus 7. And therefore you can find f of 2 plus x, because what you need to prove is that f of 2 plus x is equal to f of 2 minus x. So you replace x with 2 plus x, so you get 2 plus x squared minus 4, 2 plus x, and plus 7. So I'll skip the derivation. I'm sure you can prove it yourself, and you get a value which is x squared plus 3. And then you find f of 2 minus x. F of 2 minus x, and this is going to be 2 minus x squared minus 4, 2 minus x, and plus 7, which again, I'm skipping the expanding of the brackets, which you can do on your own, and it's going to be x squared plus 3. So according to the rule mentioned above, because f of 2 plus x is equal to f of 2 minus x, then there's an important thing. For any value of x, okay, for any value x, then x equals 2 is the line of symmetry. Okay, so no, it's not 2. Yes, 2 is the question says that. Oh, apologies. Why did I say? Okay, the question had an error. Sorry, x equals 2. I'm very sorry for that. Copy. Yes, a copy of these notes will be emailed to you. Well, you will have access to this whiteboard. As a matter of fact, I'll share it. I'll share it with you now, so you can look at it in real time. Yes, very sorry. It's x equals 2 is the line of symmetry, and not x equals 3. Right. So, and that is why I took 2. So x equals 2 is the line of symmetry. So I'm just going to reiterate that. So x equals 2 is the line of symmetry. If f of x, f of 2 minus x is equal to f of 2 plus x, for any value of x. You can even go in further for any allowed, basically for any x from the domain. Right. Okay. So anything else? Oh, yes. Oh, sorry. What I did is I didn't send it to everyone. So this is the link to the whiteboard that I'm currently using at the moment. And yes. Okay. Right. Next problem. Any questions? Any questions here before we move on? Yeah, it is live. You can track it as we go. Right. And you can create a free account to make your own whiteboards as well, which is quite handy. The only limitation is that you can't add pictures if you have a free account. Right, Unless it doesn't, unless it says do not use calculus. Yes, you can. You're free to use calculus. Absolutely. Okay. Parabola passes through the points, find the values of A, B, and C. Well, if this is the parabola, so all you need to do is just write it out. So ax squared plus bx plus c. And so it passes through the points. So that means the coordinates of those points satisfy the equation. And therefore, you can say, because it goes through the point 10 minus 18, you can say that minus 18 is equal to a times 10 squared, which is 100a, plus 10b, plus 10b, plus c, then, and I'm going to label this equation as equation 1. This is a very useful tool. So minus 22 is equal to substituting this set to the second point, which is 36a plus 6b plus c. I'm sure I'm sure most of you see the rest of the equation, the question. 196a plus 14b plus c, and this is equation number 3. This is a 3 simultaneous equations that you need to solve for A, B, and C. So of course, most of you can do it. I'll just show you an efficient way to do it. So an efficient way would be to take equation number 3 and subtract equation number 2 from equation number 3. And this gives you 24 equals 160a plus 8b. So we've eliminated c. Now we take equation 1 minus equation 2, and we have 4 is equal to 64a plus 4b. And this, let's call this equation number 4. And we'll call this equation number 5. So I multiply 5 by 2. So I multiply equation 5 times it by 2. And is somebody not muted? Please check that you're muted. Right. So I'm multiplying equation 5 by 2, and I get 8 equals 128a plus 8b, and I'm going to call this equation number 6. What I'm going to do next is I'm going to do equation number 4 minus equation number 6. So equation number 4 minus equation number 6, and what I am left with is 16 equals 32a. From here, a is obviously a half, and subbing that into equation number 5, I believe. So subbing that into equation number 5, we get 4 equals 32 plus 4b. Yes, 32 times plus 4b. From here, b is obviously minus 7. Most of you probably have already done that. And subbing that into, well, you can sub it into any equation. Yeah, but that's pretty much what I'm doing. 4 and 5. Actually, that's exactly what I'm doing. You mean by substitution? Substitution might be. Substitution is not necessarily easier here, probably. Yeah. So, and then subbing that into equation number 1, the easiest equation in my point of view, minus 18 equals 50 minus 70 plus c. And from here, c is equal to 2. So finally, we have the expression y is equal to half x squared minus 7x plus 2. And this is the answer. Absolutely. You can always solve an inverse matrix. To do that, so you can inverse matrix. Although solve the equations, well, it will be non-singular, because if it is singular, you would not have a solution, right? You would have infinitely many solutions, which the question clearly doesn't allow. Well, you would have a singular matrix in case 2 of the points are the same, and that means there's infinitely many parabolas. So I should mention, if you have 3 points, there's exactly 1 parabola that you can draw passing through these 3 points. If the points are on a straight line, it can't be done. If you have only 2 points, there's infinitely many different parabolas that go through 2 points. Any 2 points, you have infinitely many parabolas. So you can have a parabola going like this, you can have a parabola going like this, etc. And that's the case if, in this case, the matrix would be non-singular, right? But I mean, it's solving 3 simultaneous equations. Yeah, you don't have to use matrices. Okay, so solve the equation for x in your head using Vieta's formulae. And it looks like, wow, why would it look like this? It doesn't look like a normal quadratic equation. So what do we do with this? Well, first of all, we write down the Vieta's formulae, and I've written this down for me so I don't make errors, even though I have made one today. So x1 times x2. So the formulae can be found, and you need to prove those formulae. Yeah, good point. Basically, in your head means without finding without using the discriminant formula, or without using factorization or anything like that. Yeah, it means no calculator, and it means without writing out quadratic equations. You will see that the notes I make are very brief. So x1 times x2 is c over a, and this is the Vieta's formula that you can find, and this is equal to, so c is 3a squared and a is 7, so it's going to be minus 3a squared over 7. On x1 plus x sub 2, the second root, according to the formula, is minus b over a, which is 4a over 7. question 8. Yes, you need to write down this. So when I say solve the equation in your head, so for example, let's take a simple equation. Just what does solving in your head mean? In your head mean? What does solving in your head mean? So you have an equation x squared minus 3x plus 2 equals 0. So you write down, and you're allowed to do that. Yes, you write down x1, x2 is equal to c over 2, so it's 2, and x1 plus x2 is equal to 3. So basically, which two numbers multiply to make 2 and add to make 3, and this 1 and 2. So x equals 1, x2 equals 2. Okay, this is how to use the Vieta's formula in a normal setting. Okay, and this is solving in your head, even though technically you are writing stuff down, but you're not writing any solutions. You're just writing down what you know. You're just writing down the Vieta's formula, and then you write down the answers. So this, yes, I mean, the word is, it is not, because the formula is minus b. Vieta's formula is x1, x sub 2 is equal to minus c over a, and x sub 1 x sub 2 is equal to minus b over a. Now this is slightly different from the factorization that you do in school. The formula in the assignment, so here it is. It's problem number 7. It's problem number 7. Here it is. So x1, x2 is c over a, and x1 plus x2 is minus b over a. So your task is to prove that using the quadratic formula. So you write down this x1 and x2, and then you need to prove. Well, you will need to prove that. So that's one of the tasks that you need to do. Okay. So this is a very handy tool. Please don't confuse it with the factorization method that you do use in school. So this is where you might get caught up. If you're not sure, just check. This is check. So x equals 1. Does it work? And you do 1 squared, 1 plus 1 minus 3, 3 plus 2. That's 0. It works. Works. Check x equals 2. So it's going to be 4 minus 6 plus 2. It is 0. So it works. Which in the formula book, yes, of course. Apologies. Got distracted here. So yes, thank you. Thank you very much for that. And I'm just going to put it in red and save it to the background. Okay, now moving back, we have the Vieta's formulae. This is from problem number 7 from the assignment. And you use them. So x1, x2 is minus 3a squared over 7. And x1 plus x2 is 4a over 7. So it's not particularly easy to see, but you see that you always start with the multiplication because there's always fewer factors. So how can we factor 3a squared? How can we factor 3a squared? 3a squared over 7. How can we factor 3a squared over 7? Well, there's not very few. You derive Vieta's formula from Vieta's formula. You derive the Vieta's formula from the discriminant formula. If you write down x1 is equal to minus b plus root b squared minus 4ac over 2a, and then you write down x2 is equal to minus b minus square root b squared minus 4ac over 2a, and you add them and simplify, you will get c over a. Okay. I see. There's some confusion about the Vieta's formula. So Vieta's formula. Formulae. There's two of them, so that's why we say formulae. If you have an equation ax squared plus bx plus c is equal to 0, and has if the equation has roots x1 and x2, then x sub 1, x sub 2 is equal to c over a. So c over a, and x sub 1 plus x sub 2 is equal to minus b over a. So you will need to be able to prove that. They can be complex. Yeah, there's no limits for that. What is x sub 1 and x sub 2 are the roots of the equation. Yes, this is multiplication. Okay, just to be clear. So times multiplication and adding. And let's look at an example. Where do I have some space? Example. I'll just do it here. And example. So x squared, let's make it simple, plus 4x minus 5 equals 0. The roots of the equation, you can solve it, and you will see that the root is 1, and x2 is 5, minus 5. Okay. You can solve, if you solve it using the discriminant or using factorization, you get x equals 1 and x equals minus 5. So these are the roots. And let's check x1, x sub 1, x sub 2 is the multiplication. So it's 1 times minus 5. It's minus 5. So it works. X sub 1 plus x sub 2 is 1 minus 4. So 1 minus 5, sorry, 1 minus 5, which is minus 4. And this is 1 times minus 5, which is minus 5 works, and this works as well. Works because that is equal to C over A. Equal to C over A. And this is equal to minus B over A. I hope that makes more sense. That makes more sense. You can read more about it. We've done this in further math. Yeah. In further math, we do it with alpha and beta. How do we prove it without substitution? Oh, thank you. It's the 2 roots of the parabola. Yes. How do we prove this without substitution? What? I'm not sure about the question. So you find x1 and x2 without numbers. Oh, that's one of the problems. That's problem number 7. So this is your homework to prove it. To prove that it works, and you need to use the quadratic equation. So let's have a look at the question again. So how do I move that? So the question goes like that. By using the formula 2, so formula 2, where it is, the formula 2 is here. Show that the 2 roots of a quadratic equation obey the following relations. x1, x2 is C over A, and x1 plus x2 is minus B over A. So this result is the Vieta's formulae, and this is problem number 7. I think I've given enough hints. So you take this, you sub that in, and that's done. Okay. Where's the chat? Chat. To the formula. Yeah. Okay. Problem number 5. So how much time do we have? Oh, actually, we do have time. So that's excellent. Without solving the quadratic equation, so problem number 5. So this is similar to problem number. This is similar to problem number. It's similar to example number 2, and it is similar to problem number 9. So that's just similar to problem number 9 from the assignment. So without solving the quadratic equation, find this. Well, of course, you have calculators, and you can solve it very quickly. Oh, sorry. Yes, thank you. Thank you. I've went off topic. So here in this example, you have 7x squared. So A is 7, B is minus 4, and C is minus 3a squared. C is minus 3a squared. And you sub that into here, into the Vieta's formula, and you get x1, x2 is minus 3a squared over 7. And you get x1 plus x2 is 4a over 7. Would it be? No, because it's minus 4a here. And the formula is minus b over a. So it's not, b is minus 4a, but because we're using minus b over a, it becomes plus. It becomes plus. So 4a over 7. So how can we factor 3a squared over 7? Well, there are several ways. You can do a over 7 and 3a. Or you can do 3a over 7 and a. Well, there are other options. What else can it be? So we can do a squared over 7. I mean, there's a few more combinations. A squared over 7 and 3. But only one of the results actually gives us, when added, gives us this. Gives us 4a over 7. Yeah, 3/7 and a squared. I mean, you can continue the list, but once you've hit the sweet spot, once you've hit the one that actually matters, it's this one, because these can be added to make 4/7 a. And how we do it, we put a minus here. We put a minus here, and this is a. So let's double check. So minus 3a over 7 times a is equal to minus 3a squared over 7. So it works. And minus 3a over 7 plus a is in fact 4a over 7. 4a over 7. If you don't see it right away, well, do it as an exercise. So this is 7a over 7 minus 3a equals 4a over 7. So yeah, we found the answer. So the answer to this question, I'll put it in red. Answer that the first root is minus 3a over 7, and the second root, x2, is a. It's a. A question, a trial and error. You can use the quadratic formula. You can use the quadratic formula, but usually the quadratic formula is a longer method. What my aim is that you can solve quadratic equations in your head, and this is one of the methods to do it. So most quadratic equations can be solved this way. Now, problem 5 is a tough one. Is a much tougher one, definitely. Well, what equations can't? The ones that don't have beautiful solutions, the ones that have solutions with roots, and yeah, where a b squared minus 4ac is not a perfect square, but it works. It's just really hard to find the ones that won't give you the answer. Problem number 5, without solving the equation, find this. Well, this is clearly a case of Vieta's formulae. So right away, we write that x sub 1, x sub 2 is c over a, which is 1 over 2, so it's 1/2. And x sub 1 plus x sub 2 is 5 over 2. And then we look at this. Well, if you look at the examples, you will see that there is a way to find x. If you do x1 squared, x1 plus x2 squared, if you do squared, you will get x1 squared plus 2x1 x2 plus x2 squared. All right. Okay. Rearranging that, I can get x1 x1 squared plus x2 x sub 2 squared is equal to x sub 1 plus x sub 2 squared squared minus 2 multiplied by x1 x2. So basically what we did is we wrote down x1 plus x2 squared, we expanded it, and then we rearranged it to make this the subject. We won't need to, we will use it later on, but for now, I'll just x1 plus x2, we already know it's 5 over 2. So it's 5 over 2 squared. Okay, that's not what I intended to do. Sometimes can be a bit awkward. x2 and 5 and minus 2 multiplied by x1 x2 is 1/2. So it's 1/2. And after simplification, you will see that it is equal to 21 over 4. Okay, that's an important result which we will use later on. And now we do a very similar thing with x1 plus x2 to the power 4. We expand this using the binomial expansion. So x1 to the power 4. Sorry, this will take some time. Plus 4x sub 1 cubed x sub 2 plus 6x sub 1 squared x sub 2 squared plus. I hope you all know how to do binomial expansion. If you don't, do look it up. But you can just literally do a plus b times a plus b times a plus b times a plus b. And when you simplify, you get that x1 x2 cubed and plus and thank you, x2 to the power 4. And then rearranging it, you get x1 to the power 4 plus x2 to the power 4 equals x1 plus x2 to the power 4. So I'm just rearranging it. So I'm taking a few things to the left-hand side. I'm taking this, this, and this to the left-hand side, and I'm leaving this, and I'm leaving this. So I get minus 4. So I'm combining these two, and factorizing them right away. So just don't want to. I'll just say that I kind of missed a few steps. Yep. I'm just saying that I kind of missed a few steps here. So 4x1, x2, open bracket, x1 squared plus x2 squared and minus 6 is the common factor. 6, oh yeah, I'll just open the brackets, x1 x sub 2 to the power 2. And so that is, and you kind of already know all this stuff because you know x1 plus x2, you get it from here. This goes from here. x1, x2, that's here. x1 plus x1 squared plus x2 squared, that's this bit. And this bit is here. So you have everything you need. So x1 to the power 4 plus x2 to the power 4. You get, so it's 5 over 2 to the power 4 minus 4 times a half times 21 over 4 minus 6 times x1, x2, so that's a half squared. And after some magic, the term with a I don't see how many factorize the bracket like that. The term with coefficient 4x. Okay. Would it be easier to square this? Yeah, you could do that. Actually, yes, thank you. That would be an easier method to square that and to get a slightly easier result. But I don't know. I like binomial. So this how to factorize this? So look, I did not factorize this, and this is an important thing. I did not factorize this. I didn't do anything with it. What I did is I rearranged it so that I have this term and this term on the left and everything else on the right. And once I rearranged it, so this bit comes from here. So it is 4x1 cubed x2 plus 4x1 x2 cubed, and this is 4x1 x2 open bracket x1 squared plus x2 squared. Yes. And finally, after doing some magic with algebra and fractions, and hopefully without using a calculator, just like I did a couple of hours ago, and you get the answer is 433 over 16. And please never use mixed numbers. Just forget about just forget that they exist. Okay. So the answer is I'll just reiterate that the answer is 433 over 16. Okay. So this is just doing a lot of algebra and doing it very, very carefully. Okay, moving on. We have about 15 minutes left. Can we do? I definitely. Okay, I'll skim a bit, somewhat quickly through this one. So problem number 6. Problem number 6, this is a factor of this. Find all the roots of the equation. Okay. So basically, this is a factor of this. That means, I know it is the factor theorem. I know that this actually means that f of x is equal to, it is algebraic long division, x squared minus x minus 6 multiplied by something, because that's the definition of what factor is. So if this function f of x, which is just a short way of writing this, is a factor. So this is a factor of that. That means that f of x can be written like that. That means that we can divide f of x by this. And how to do long division? Some of you haven't seen long division yet. Some of you have. So if you have, please don't be too bored. So x squared. So x squared goes into x to the power 4 x squared times, and then x squared times. And now you do x squared times x times this, and this is x to the power 4 minus x cubed minus 6x squared. Now you subtract, and this is minus x cubed minus 11x squared. So this is quite a straightforward process. It's not much harder than long division. Then you drop down 18x. Now you do x squared goes into minus x cubed minus x times. So minus x, so minus x cubed plus x squared. You could, yes, absolutely. This is a method of unknown coefficients. You could replace it with, although you do have to justify why you're using A, B, and C. A, B, and C. So you don't understand. So I'm saying, look, I'm saying that if this is a factor, so if A is a factor, okay, I'll just use it. If A is a factor of B, if A is a factor of B, that means B can be written as something times A multiplied by A, right? So in this case, if x squared minus x minus 6 is a factor of f of x, that means that f of x can be written as something, that should be a dot, something or something multiplied by x squared minus x minus 6. You could replace the something with ax squared plus bx plus c, but you need to justify why you chose that. And rather than justifying, and then you can say that this something that you're looking for is actually equal to f of x divided by that. And that's what I'm doing. I'm dividing x4 minus 2x3 minus 17x2 plus 18x squared, 18x plus 72. I'm dividing by that. I know a factor, so I'm doing long division. So I subtract that, and I get minus 12x squared. So find. I think we have a video on long division. So do have a look at the video afterwards. I think it's included in the assignment. 12x squared plus 12x plus 72, and the remainder is 0. Therefore, we have concluded that this f of x is equal to x to the power 2 minus x minus 6 multiplied by x squared minus x minus 12 minus x minus 12. These two can be further is this this is for year 12s. I know most of you will do this closer to year 13, so you will do this for A level. If you haven't, do watch a video on long division and try to figure it out. But there's only one question there, so don't worry if you don't get it. Yeah, like if you're completely lost with long division, it's only one question. And and then you can factorize these. You can factorize x squared minus x minus 6. You all know how to factorize, and you get x minus 3, x plus 2 sorry, x minus 3, x plus 2, x plus 3, x plus 3, and x minus 4. And from here, you get the solutions. You get the roots of the equation. So answer is x1 is 3, x2 is minus 2, x3 is minus 3, and x4 is 4. If you haven't done this yet, you will do this you should do it in A level later on if you haven't already. So this is like a very, very core stuff that you really need to get your grips on. And inspection, yeah, inspection. You can use inspection here. Right, this is A-level maths. This is not further maths. This is yeah, long division. Long division is quite straightforward. If you understand it once, it just clicks. You start understanding it. Right, I know I left this a little bit hanging. I know some of you are struggling to get that. Do try. But as I said, if worst comes to worst, if you're completely lost with this question, I think it's just one question here. This is from the Pat. Yeah, so this is very similar to this question. Actually, what you can do is you can follow my solution and you will be able to get it. If you just, okay. Right, and moving on to question 7. A physics webinar is next week. You should have received an email for the physics webinar. Now, problem 7. This is a very tricky one. I didn't know if I wanted to add it. But this appears to be a quadratic equation. And then a super weird question. Has more than 2 real roots. Like, why on earth would a quadratic equation have more than 2 real roots? So let's investigate. Well, we know what we know. We know if the discriminant d squared minus 4ac is greater than 0, we have 2 real roots. We have 2 real roots. If the discriminant is If the discriminant is 0, we have one real root. One real root. And if the discriminant is less than 0, then we have if discriminant is less than 0, then it is there's no real roots. Now, well, yes, but no real roots. No real roots. But it says more than 2 real roots. So we know that if it is a quadratic equation, then it can have 2 roots, 1 root, or no roots. It will be a different link. It will be a different link. Who can tell me? Who can tell me what's the deal? Like, okay, who can tell me what's going on here? Like, how do you even approach a problem like this? But that doesn't answer the question, because we know that if it is a quadratic equation, you can have 2 roots, 1 root, or no roots. No complex numbers. That would be cruel, adding complex numbers in the first assignment. Split into quadratics. Coefficient is a quadratic. Cubic. Well, there are no cubic equations. This is a quadratic equation. Well, it appears to be a quadratic equation. Factorize the quadratic coefficients. You did. That is a very good way. Angela, well done. Absolutely, you got it. You got it. So the conclusion is inescapable. If a quadratic equation has 2 roots, 1 root, or no roots, that means this is not a quadratic equation. And we need to explore when it is not a quadratic equation. So if it has more than 2 roots, it is not a quadratic. If it's not a quadratic, right, so yes, please keep the chat professional. Thank you. It's not a quadratic, and that means, well, when is it not a quadratic? It's not a quadratic when the leading term is 0. It is not a quadratic when the leading term is 0. Okay, so that means that a squared plus 2a minus 8 is 0. So solving by Vieta's formula, we get a equals 4, a equals minus 4, or a equals 2. A equals 2. And all we need to do is check both solutions. Just substitute both solutions. Look, if it has more than 2 roots, then it is not a quadratic. So this has to be equal to 0. So this term has to be equal to 0, because then it is not a quadratic equation. If this is not a quadratic, and this happens only if a equals minus 4 and a equals 2. So let's write out the equation for both cases. So case 1, a equals 2. So that means that 16 minus 2 squared, so that's 12. Okay. 16 minus 2 squared x plus so 4 plus 44 plus 28 4 no so 4 plus 22 plus 28 28 plus 22 is 6 is 50 50 plus 454 54 equals 0. I made a mistake here. So we got 12x plus 54 equals 0. Without solving it, I know it's one root. So a does not work. So one root. So it doesn't work. So case 2. This is because this is a linear equation. Case 2, a equals minus 4. And now we see some magic going on here, because the leading term is 0, so it's 0x squared plus then 16 minus is 0x, and plus a squared plus 11. So when you sub 4 in, you get 0 as well. Plus 0 equals 0, and this has infinitely many solutions. X is any real number. So infinitely many solutions. Okay. Now, why the first quadratic has to equal to 0? Because it's a quadratic equation cannot have more than three roots. That means this is not a quadratic. It is not a quadratic when the leading term is 0. So ax squared plus bx plus c is not a quadratic, if a is 0. Simple as that. How do you write in the neat handwriting? Make it with this structure. In the future. This is just use the I drew. Use I drew. You can always download a PDF version of this. How do you write? Yes. You submit homework on the whiteboard. I'd rather you not. It will make it a hassle to mark. We do want it to be in a PDF. If you want to do it on a whiteboard and then do a PDF, yes, by all means do that. But as long as you can do a PDF version, because the tutors will mark your work based on from the PDF. So please do it in PDF format. Now we've run out of time, but I just want a few words about this one. So one thing that you're not really taught in school is to watch out for the domain. Watch out for the domain. So here, watch out for the domain. Why am I saying that? Well, this there are some points that are not in the domain of the equation, and you always have to check that. I mean, in A level, they make it real easy for you, and they tell you that x is not equal to something, but sometimes you have to do it yourself, and this is part of the analysis. So you look at the problem. Can x be any number? Well, certainly not. You're not allowed to divide by 0. So in this case, x is not equal to plus or minus plus or minus 1. Because if x is 1, you're dividing by 0. Same here. If x is minus 1, you're dividing by 0. This thing is always positive. This is a quadratic with no real roots, so this is always positive. So you don't have to exclude, but just watch out for the domain, because if one of the answers is 1 or minus 1, you need to exclude them. Okay, so that's domain is the range of possible values of x. That is the definition of the domain. If you don't know what domain and range is, this was in GCSE, so do revise that. That is a very important thing. Watch out for the domain. Domain is the range of possible values of x, and the range is the possible values of y. And then here you just do it as normal fractions. Yeah, so hopefully I'll just give you a hint that this thing can be factored into x plus 1 and x squared minus x plus 1. This thing factorizes into this, and this thing factorizes into x minus 1 and x plus 1. X minus 1 and x plus 1. And then you just need to multiply this by something, multiply this by something, and multiply this by something. Okay. Hopefully I hope that helps. There is a video, so looking back, equation of the parameters. So equations with rational expressions. There are 2 videos from Khan Academy, and they will help you. They will guide you through solving equations with fractional expressions. So equations like this. Okay. Right. Okay, so hopefully, I really hope that helped. So I'll resend the link to the whiteboard. I'll resend the link to the whiteboard. Oh, why am I sending it? I resend the link to the whiteboard so you can look at it at any time. It will stay there forever. It's not going anywhere. And I really hope that helps. Just one last question before you go. I do have a one question poll for you. So copy. How do I copy link? And one last poll for you. Please please respond. Okay. The recording will be sent either actually it will be both. It will be sent to you by email, and it will be posted on the website. Posted on the website, so you can. Excellent. So we got some responses, and okay. Good. Okay, excellent. Thank you for your feedback. Thank you for your time. And I really hope I wish you all the best.